progress.
हरीश, झूम 2 ला पण ऑनलाईन लेक्चर आहे. मैम आपकी आवाज नहीं आ रही है मुझे। यस मैम अभी आई।
So, yeah. So, for sine angle or any kind of sine, cosine, or whatever geometry we were talking about, what kind of triangle do we choose? Right angle triangle. So, let's start with the right angle triangle.
Ma'am, we cannot see the board on the main screen.
All right, I'll change. You cannot see the board. You cannot see
Yes,
the
ma'am.
board or anything.
No, sir. Ma'am, I cannot see the board on the main screen.
नहीं दिख रहा है मैम। नहीं ऐसे नहीं रहेगा मैम। आई कॉल टू हरीश, यू कैन कंटिन्यू मैम।
You know what is to be done. Okay. So yes, so what I was talking is about this ideal plan. So we were talking about sine angle. Okay. So what is sine is we take right angle triangle. Let's name it anything. Put ABC. All right. And we already know one angle for sure, which is 90. We are left with two angles. You can choose from any one of these. Okay. Okay. Let's presume I choose this one. So this I name it as theta. Okay. What sine, cosine, or all of those what you have studied in geometry is nothing but ratios. You know what is ratio, right? Yeah, it is division between two numbers. Okay, so it is ratio, and they have given these ratio specific name. Okay, so like for sine, like I did last class, I was saying sine angle, sine. Let's say sine means with respect to this theta we call it. Why we call theta also we will discuss. So sine is ratio between. This is what AB, which is opposite to this theta. Okay. In your textbook, they call base height also. It is up to you, whatever you want to understand. So, what I use is, so whatever is opposite to theta, we choose that side. So, ratio will have, of course, ratio between two sides, right? So, one of this is this, and the other one is the hypotenuse. And hypotenuse is AC. So, it is AB upon AC. So this is ratio between these two sides, and we name these two sides as what? Sine. Okay? And there is something called cosine also. So cosine would be what? A ratio between other two sides. Like for cosine, it is the base or adjacent side to this theta upon hypotenuse. Then there is something called tan. Again, what that will be? Ratio between two sides. Of course, these two are named. These two are named. That will be what opposite upon this. So it is nothing but ratio between two sides. Now, why do we not write like these, and why do we give names like this, and then we, talk it with respect to theta?
To simplify the way.
Yes, so in last class I think I was discussing to simplify why to write these complicated things. But then why with respect to theta is very interesting. Why this ratio, if I extend this, okay, if I extend this triangle and then I draw like this. I get another new right angle triangle, right? And if I choose these sides, like say this is x and y. Okay, so what is opposite to this theta? It is yx, right? And what is the hypotenuse in this triangle? It is cy or yc. You will see that ratio of this is also equal to this. Okay? No matter you take it to chintu sa triangle or itna bada sa triangle, the ratio of those sides would be same. That means that it is dependent on what? Theta, right? Because the only thing that I have to change when I want to change this ratio is I will change the angle and then I will get new ones. Are you getting the point? So why they are specifying it with respect to theta? Because theta is the component which can change that value for ratio. You will not change or if you're magnifying or diminishing that triangle. Is this part clear? So what is sine? You can call it height upon hypotenuse. Maybe I think Cbse that's about it. Or you can also take
Opposite.
opposite only. Oh, that's great. I love that. Remembering. So it is opposite upon hypotenuse. What is opposite? If in this case this was my theta, so the opposite side was AB. But what if this is not the theta that I'm considering, and this is the theta I'm considering? Then what? Can you tell me what is sine?
CB by AC.
Yes, so opposite is what? CB, and what is the hypotenuse? It remains same. So it is CB by AC. All right, this is clear. So let's jump to what we were doing in last class. This is refraction. All right. Yes. So I think in last class we saw what happens if this is my medium. So please answer me so that I will understand how much was retained and how much was lost during the last class. So this is my glass and ray is falling. So I think I did not discuss this much. Let's say ray falls perpendicularly to the glass slab in this direction. What will happen? Will there be bending or not?
None.
If you can think and whatever answer comes to your mind, you can say. Like we already saw what happens, right? In case of it is hitting at an inclined angle, if I'm not wrong, right? So for this case, what will happen? Like, will it bend? Will it bend or will it not bend?
And
So
because it is towards the normal, it's already 90 degrees.
yes, but my question is not that. I don't know. I have just a simple question. Okay, I don't know what you added to it or what, but it did not answer my question. My question is simple. मेरी ये रे इंसिडेंट भी इस केस में हम पिछले क्लास में किया था मेरा मीडियम से डेंसर मीडियम में आ रहा है तो इट विल बेंड व्हाट टुवर्ड्स द नॉर्मल ये हमने डिस्कस किया था राइट मैंने भी ये सवाल पूछा कि अगर ये सीधा गिर रहा है सीधा इन द सेंस नॉर्मली ही रे गिर रही है तो क्या यहाँ पे कुछ बेंडिंग होगा नहीं होगा सो आई जस्ट वांट द आंसर व्हाट डू यू थिंक it will not no. Okay, one of you can you tell me why it will not?
Because it bends towards the normal and it is already falling perpendicular.
Alright, a good logic.
Ma'am, because it is falling straight, so it is for one straight, it may like spread, not like spread and spread.
And when the perpendicular is the shortest distance, to cover that glass, that's the shortest distance.
Alright, put any other additions to that? Yes, that is pretty much very close to the answer. I think we had discussed the main factor. ये सारा जो diffraction करता है किसकी वजह से हो रहा है? Like which is the property of light which is doing all these things? What is the one which is responsible for it? Speed of light, right? So what happens is जब आप like I tried this way in other class, I understood. I guess even you will understand. It's not that good ray. So when ray of light is hitting in bent manner, so let's say हमारे ray wave आ रही light.
Excuse me, ma'am.
Yes, Aditya, what happened?
Ma'am, we can't see the right side of the board.
All right. So you tell me up to where can you see?
No, ma'am, we can't see the board.
What?
Yes, ma'am.
She told right that she will call something. Board. Aditya, are you able to see this part?
Yes, ma'am.
Oh, and you're not able
Ma'am,
to see.
now, ma'am, now.
Aditya, just
Okay.
see whatever is the problem. He has come to fix it. All right. So where were we?
अभी दिख रही है?
ये अभी दिख रहा है ये part?
No, ma'am. बस एक like थोड़ी सी line दिख रही है.
Okay, I think I will not. इधर का part दिख रहा है?
Yes, ma'am.
All right. ठीक. I will not use this one. Thank you. Yes. Attendance sheet is there. Can you check at what time is it ready for? I have not put alarm. I might take extend.
12:30. And then another question for 12:30.
So 12:30 you can maybe 10 minutes before that. Yes. So yeah. So in this case, what happens is when this is. So when light ray is hitting, light ray is what? Light is made up of wave, light is wave, light is particle, whatever it is. So if you do not know, it's fine. So let's say light is hitting like this. These are all those light waves that are coming, the packet of light waves that are coming. When it is at inclined angle, when it is hitting, you see that when this part hits, it has to face what? This denser medium, speed of this part reduces, but speed of this doesn't reduce. It goes with the same speed. Okay. As it moves ahead, यहाँ का speed कम हो गया, but ये वाले normal speed से जा रहे हैं. That results into bending. But in this case, when they are coming, when they hit, all of them hit together, right? And then speed of everybody changes together. That is why we do not see bending over here. If you want to imagine, let's say आप सारे बच्चे लोग हाथ पकड़ के जा रहे हो and you're crossing this together. If you are hitting, your speed will remain same because you are hitting the barrier together. But in this case, this one fellow hits the barrier earlier. Okay, his speed reduces, and that change, if you see the chain होगी वो, because तो ये सारों को pull करने लग जाएगा इस तरफ. I don't know if I'm trying to depict or portray in the same manner. So as they move inside, these fellows will, pull them because they are slower. So they will pull them towards under the side. So that is why you will see that bend happening. So simple way to depict why speed of light, affects this inclined angle में bending, but it doesn't allow bending in this case. Okay, so this is the case, and like we saw in mass class. So the crucial characteristic which is playing role in this whole refraction part is what? Speed of light. And we came across two laws of refraction, right? So can somebody tell me at least the first one, first law of refraction?
The incident ray normal and the reflected ray are
So they are all on the same plane. And the second one, which was very important, was what? With respect to geometry part that we saw. What does it that say? Can you tell me?
Incident angle is equal to reflected angle.
That is for which case?
Mirror.
Yes, and mirror is which case? Reflection, right, Aditya?
Yes, sir.
Yes, so I want second law of refraction that we saw with respect to sine, if I'm not wrong, right? So what did that say? It said, again, that was full with respect to the ratio. So in that case, said sine I upon sine R is what? Constant. So what is light ray starts from here? So this is my incident angle. This is my what? Refracted angle. And sine I by sine R is what? Constant. Okay. And what do I call this constant as? Refractive index. Okay. Refractive index, I call it. I give you time to write because there's a lot of things that is going to come. So please pay attention because now the whole khichdi will come very little confused. So this is sine I by sine R, which is constant, and this specific law of refraction, we call it Snell's law of refraction. Okay. So what is this? It is sine I. Now you know what is sine I, right? So if you draw anywhere the perpendicular, here, whatever, the ratio of opposite to hypotenuse or this or to hypotenuse, that will represent your sine I. Similarly, sine R. Okay. So it doesn't depend where you are drawing this perpendicular because you know it is independent of that, it is dependent on angle. So sine I by sine R is constant, and I call it refractive index, and the other name for this is Snell's law of refraction. Snell's law of refraction. The important thing over here is that this refractive index in sine I by sine R, which I'm calling constant, it is constant for with respect to what? Pair of media. So for air and glass, it is constant. But what if I change it air to water? Will it be same to the previous one? No. So for each pair of media, it is constant. So for a given pair of media and for given color of light, or for given light color. So you all know our normal light, which we have, it's made up of how many colors? 7 colors. And each of that color is also having different speed. Okay, it's just that when we are talking about this thing, so you will see in your textbook, and even when you are defining what is Snell's law, you have to make sure that you are putting it very clearly that it is sine I by sine R is constant for a given pair of media and for the particular light color. Okay, for each light color also it is different. All right. Okay, like yes, any question? So like our blue is there, our red is there. So we have different colors of light. So red light is the fastest, blue is the slowest. You don't have to know this. I'm just telling you, you don't have to remember this also. But then you have to put these parts. These two parts are very important. Okay. So when I'm saying refractive index, then again refractive index is what with respect to pair of media. So again, while denoting it, we have to represent it. So either in your textbook they are using n. N represents what? Refractive index, and they put two numbers or something like this, like 2, 1, 1, 2, or whatever. So these numbers in the subscript position, they represent what? Pair of media. What am I using? For in this case, the two pair of media are what? Air and glass. So for that thing, how will I represent? I will say refractive index of G with respect to air. Okay. So in this case, when I speak sin I by sin R, this sin I by sin R, it will be refractive index of glass with respect to air. Is this clear? Okay. So the main medium is written first, and the surrounding medium, surrounding the medium, like from where the light would come and hit the medium. I call it surrounding medium just for easy way to put it forward. So that comes second. So if I'm writing N1, 2, then first one is my main medium, second one is the surrounding medium. Okay. And the other places, I think the other students were saying that even this letter is used to denote. It's the symbol called mu. I don't know if you have heard. It's like mu, mu. So this mu letter is also used, and here they use different way of denoting it. So they will write something like 2, 1, aage piche kuch karke. There's no need to get confused how to read this. It's the same way. So next likha hua hai baaju mein, that is the main medium. So refractive index of glass with respect to air. There's no need to worry with the denotation part. So either it is represented by letter N or mu. Even if they come across with something new, there's no need to worry. Once this is clear in your head, that the first medium is a main medium and the surrounding medium is this. Okay. All right. So this is the thing, and I think the speed ke saath jo tha last time ka confusion wala. You can copy this part and we'll go to that next. With speed part. These all numerical also to understand. So I think the diagram should be. You can draw one normal wala also if you want. If you don't want, it's fine. How to read this, okay, in bracket. So put how to read this refractive index of glass with respect to air. Or if we write N21, then give me answer for this. How will you read it? You can write it by common sense because any picture is won't take much time. You have to copy what is there on the board.
We already wrote this.
You wrote this in last class.
Yeah.
So whatever is left because somebody was copying it. So whatever is not undergoing, please copy it down. If you are done, let's give it. Yes.
The difference between the speed of different colors of light will be very small, right? that's why we don't. We can't really notice it in here.
We actually do not, it's white light group together, so we do not see the white lights. The very crucial part where you see, we'll come to that part as well. It's always the angle also which plays very important. For rainbow thing also, if you have seen, the particular angle with which you are viewing makes a lot of difference whether you are able to see the rainbow or not. So that plays very important role in light. We'll come to that question as well. Remind me to put that when you are doing prism part. You are doing yes.
After that, you know, the second index of space, that is data one constant.
Okay, in mathematics we say it's with respect to, I put WRT. So don't use that symbol, don't. It's WRT with respect to air. All right, can I quickly come and check what you have written for this? What they want, or you can read it. One can read. How do we read this, beta? Yes. Yeah. No, there is no glass and there is no air. It is 2 and 1. So we put medium 2 with respect to. So the refractive index of medium 2 with respect to medium 1. All right. If I want you to, you know, let's say I'm just giving you a question where you label something. So I am asking you to, this is my medium for this is medium 1, medium 2, and for this thing, refractive medium, I'm already given that it is equal to sine I upon sine R. All right, and I'm giving this right now. Okay. Okay. Can you tell me which one is I? I mean, there is a bend. So which one is I? Is this I or this R or this I or this R? When the formula is this. Or else you can tell me the arrow's direction, like ray is going from this way or this way. Presuming this is the formula which is given. And it is going upwards. Let's see what happens when it is going upwards. This will become I. This will become R. So that means R जो है refracted वो तो main medium की बात करेंगे तो यहाँ पे main medium हो जाएगा 2 and surrounding medium line वहाँ से आते हैं so 1. So this is correct. So in this case it is moving like this ulta. Okay. So sin I, sin R, everything is correct. I have just switched this one upon 2 for 2 or 1. I hope this is not confusing. I'm just trying to tell you that surrounding medium the next medium होता है वहां से लाइट आती है सो एरो की डायरेक्शन ऐसी होनी चाहिए और रिफ्रैक्टेड पार्ट जो है वो मेन मीडियम के बारे में हम बात करते रहते हैं व्हेन यू आर यूजिंग sin I by sin R formula. All right, so let's move to the other part. So what is that other thing? So I told you that in last class, let's say MGA, it's refractive index of glass with respect to A. So we now know the one way to give that is sin I by sin R. The other way of giving that was with respect to speed of light in these two mediums, right? So how do we give that? So what is this? Refractive index of glass with respect to air is speed of light in what? What is the ऊपर क्या आता है? Air. The surrounding medium comes first. Speed of light in air upon speed of light in our main medium. Okay. The way they represent air का speed is small c, and we all know that is what is speed of light in air? 3.8 to 10 million power. That's not 3.8. 3 to 10 to the power. So this is my formula. Okay. Again, if I write it like this, then what is my surrounding medium? 1. So what will come over here? Speed of light in 1, and यहाँ पे क्या जगह नीचे? Is this clear?
Yes.
Is this clear? Now, this is refractive index. Okay. Now you see that when I have not written anything, if I write only just G, so what is the presumed part की surrounding medium क्या होगा इसका? Air होगा. So then, if nothing is written next, so we presume that it is air, which is the surrounding medium. I'm sorry, the velocity of speed in light upon. Okay. All right. Now, I think I did ask this question. So, whenever we are talking about moving from denser to rarer or rarer to denser, I don't know if we discussed this. So, all this density is what? Our normal density was what? Mass upon volume. Okay. In this, when we are talking about optically denser medium or we are talking about denser medium and rarer medium, they actually mean optically denser and optically rarer. So density जो है वो हमारी normal density की बात नहीं करते, हम यहाँ पे कौन सी density की बात कर रहे हैं? Optical density की बात कर रहे हैं. Optical density कैसे define होगी? कि आपकी जो light है, the main thing जो हमने पढ़ा था कि what is optical density? When light passes through that medium, ठीक है? So वो जो medium से pass हो रहा है तो वो medium जो speed की light को कितना कम कर रहा है? That is what is optical density. तो जितना denser medium होगा, speed उतनी क्या हो जाएगी? स्लो हो जाएगी. ठीक है. जितना डेंस मीडियम आ रहा है उसकी स्पीड क्या कर देगा? वो स्लो कर देगा. ठीक है. एंड उतना ही हमारा नॉर्मल जो रिफ्रैक्टिव इंडेक्स है. सो इफ आई से रिफ्रैक्टिव इंडेक्स ऑफ ग्लास, let's say it is 1.7. I'm just giving some number. Let's say there is another more denser medium. Let's say more denser than glass. Some random medium called D, okay, and its density is 1.8. It's very dense, okay. So what can you conclude for velocity of light in both these medium? Can you give me a comparison, like of velocity in glass and velocity in medium D? मैंने कहा ये काफी denser है और ये क्या है? Less denser है. ये refractive index को भी नहीं करा रहा, because दोनों का comparative medium क्या है? सेम है. एयर एंड सेम होता है. सो इसका रिफ्रैक्टिव इंडेक्स इतना है, ये ज्यादा डेंसर है. सो वेलोसिटी का कंपैरिजन किससे हो जाएगा? बिकॉज़ जितना डेंसर में चला गया स्पीड क्या हो गई? रिड्यूस, कम हो गई. सो दैट मींस दिस इज मोर देन दिस. ओके. वी ऑल नो वाटर, राइट? सो वाटर and ice. You did this in last class, right? Yeah. So can you give me correct answer for this? So if velocity of light in water and velocity of light in ice, इसके बीच का comparison क्या होगा? और आप मुझे फिर comparison बताइए refractive index of water and refractive index of air. You got the question, right? Yes. आप दोनों में से पहले कोई भी define कर लीजिए. Optical density किसकी ज़्यादा है इसमें से? वाटर की डेंसिटी ज्यादा है ऑप्टिकल वाली की. तो जिसकी ऑप्टिकल डेंसिटी ज्यादा होती है उसका रिफ्रैक्टिव इंडेक्स क्या होता है? ज्यादा हो जाता है. इधर ही देखो, ऑप्टिकल डेंसिटी ज्यादा तो रिफ्रैक्टिव इंडेक्स भी क्या है? ज्यादा. सो व्हिच वन इज ग्रेटर, वाटर और आइस? वाटर. सो रिफ्रैक्टिव इंडेक्स पार्ट यहाँ है. ठीक है. तो रिफ्रैक्टिव इंडेक्स तो इसका ज्यादा है, और जितना रिफ्रैक्टिव इंडेक्स ज्यादा है, जितना वो ज्यादा डेंसर है, स्पीड ऑफ लाइट उधर क्या हो जाएगी? स्लो हो जाएगी. Now the speed of light क्या हो जाएगी? This is clear. और this one? Sorry. Yeah. So it's yes. So there is one interesting question in your module which had like appeared in some of the year. So this, if this logic is clear, then you can answer those questions very easily. What is the logic? आपका refractive index जो है दो मीडियम का, जिसका ज्यादा है वो क्या है हमारा? ज्यादा डेंसर हो गया, और उसमें मेरी वेलोसिटी क्या हो जाएगी? कम हो जाएगी. ठीक है. सो देयर इज वन क्वेश्चन. आई विल चेक इफ आई एम एबल टू सी दैट एंड आई टेल यू टू सॉल्व इट. सो I was asked to ask you to copy that and everything. Please. Okay, I'll write it again. By then you can solve the question. show me their other volume. Just don't understand why I did not get questions here. Okay, the question, I remember the question. So question is like this. So there are three mediums. This is one, this is two, this is three. Okay. And if you see any kind of question like this in the volume, please let me know where it is. So the ray, light ray, goes like this. Yes, it's question number 9. Yes. Yes. Question 9, page 35. Please solve that question, right? Solve that question. Page what? Give me the page number. Page 38. 38 question 9. So you check the question, try to answer it, and by then I will draw, and whatever I have erased, I will redraw that as well. Vedanta and Aditya, it's page 38, question 9. Yeah. Yes, it's all that. And tell me what's the correct answer. You know all the concept that is required to solve this question. It's not tough at all, but it's not that easy also. Just simple logic that we just applied. Just think of that. Page 38. Yes, what's the answer? Okay, let's see. B. B or D? I'm here. D. Okay, take for Delhi. Delhi, everybody? What is your answer? Okay. But then, yeah, this is the first class all right. But then still, you try to solve it because we have discussed, yeah. So yeah, what is the last? Let's give me the all options. What is the first options? N1 is equal to N2. So N1 is equal to N2. Vedant and Aditya, what are your answers?
Ma'am, I think it is D.
Okay. Aditya?
Okay.
Second one?
N1 is greater than N2. N2 is greater than N3. N3 is greater than N1.
Okay, Aditya, take a look over here. So first thing that you see is in every case it is bending. Although there is very slight bend, so in all the cases there is a bend. That means all the three mediums, any like two of them are not same. Otherwise, if they both are same, then it would have just gone straight away. Like air ही होता, बस एक बीच में line करके आपको 1 or 2 लिख के होता, और दोनों medium air होता, तो वो बिना deviation के चली जाती. तो ये first case तो कहीं है ही नहीं, इनका that every point we see there is slight bending. Okay. Now what we see another thing is how much is the bend. So we see that in first case हल्का सा bend था, right? So that means N2 medium denser है, right? N1 से अभी towards the normal bend है. यहाँ पे जो हमने देखा कि और ज़्यादा bend है, ठीक है? So what is N3 or N2 comparison? Again N2 refractive index of this is more than N2. Then we put it together, it becomes N3 greater than N2 greater than N1. And we see that over here Only in this case does it satisfy this case. So that's the answer. So quite happy that everybody was able to answer this. And were you all able to copy that part? I erased it. Do you want to rewrite it? Should I rewrite that? The N2, N1 or no? Part velocity while light ka written, right? Yes. Okay. Wait. Let me see if there is another question. Okay, can you give me answer for the question 10? Question 10. They are given refractive index of both the mediums. They are asking the same page 38, question 10. They are given refractive index of both the medium. What is it?
Should be D.
Okay, D, let's see. Can anyone read it? Can you read it quickly?
Yes. The refractive index of medium A is 1.5 and that of B is 1.33. If the speed of the light in the air is 3 into 10 raised to 8 meter per second, what is the speed of light in medium A and B respectively?
So the mediums, refractive index of each of them. I know speed of light. I need dA. I need dB. I know the formula for this. What is the formula? What is the formula for refractive index of
C by B.
light in air? Speed of light in air upon speed of light in the medium. So dA. This is my formula. Speed of light. C का मतलब होता है speed of light in air और ये है speed of light in medium A because हम वो medium A का refractive index ढूंढ रहे हैं. By that answer and they are asking me to find what VA. So what is VA? VA will be what? C upon NA, right? Similarly, NB पता है हमें NB is equal to what? C by BB. वो हमें BB ढूंढने बोल रहे हैं. BB is equal to what? C by NB. आपके पास C है, आपके पास NB है, आपको सब डिवीजन है, तो थोड़ा कॉम्प्लिकेटेड हो जाएगा. So I think in this case, I think they are making it very easy for you. 3 into 10 to the power 8 upon NA क्या है हमारा 1.5. So ये हमारा 2 हो जाएगा. 2 into 10 to the power 8 meter per second. And here I think there will be, you have to solve it properly. But is there any option which has only 2?
There are two options, but
Okay.
the first option on it has 1.33, and since the refractive index is lower, it can't be.
It cannot be 1.33. All right. So there are the 3 into 10 to the power 8 upon 1.33, and our answer would be, I think, what are the 2 options? Let's select the best from that. One is what?
A is 2 into 10 raised to power 8 and 1.33 into 10 raised to power 8, but that can't be. So now it is B.
What is B?
2 into 10 raised to power 8 and 2.25 into 10 raised to power 8.
Okay. So it is understood when it is divided by 1.3, 1.5 आपका आंसर 2 में है, और आप अगर 1.3 उससे भी छोटे नंबर से डिवाइड करोगे तो आंसर 2 से बड़ा ही होना चाहिए. So आप ऑप्शन में से आराम से बिना सॉल्व किए सिलेक्ट कर सकते हैं. 2.25, right?
Yes.
2.25 into 10 to the power 8 meter per second. This was simple usage of the formula. Okay? This was not anything which would require too much of brainstorming also. Straight away, everything is given, you just put it. If you're done, let me know. Small groups now, please. I think we'll now go to another part, then come back to numericals. Your Cbse sticks to this. I have just given your Cbse textbook also gives. Oh, she is asking me which one is more appropriate. Is NGA, this is more appropriate, or NUG with respect to A, this is more appropriate. So as far I know, your textbook is giving only this one, N, medium refractive index of G with respect to A. This one I've given just in case such thing comes, you do not panic. Okay, it's there in some of the Cbse past year question papers. They have used these denotions. You should not panic. You should know that some kind of these representation is also used. This is an experiment. You stick to one which is given in your textbook if you are providing it from your end. But if you are receiving it from the question paper in some other manner, just accept it. You know it, right? So that's it. You stick to this one. All right. So are we done? Yes, ma'am. All right. So now there is one experiment. Is this chapter done in your school? No.
I'm started.
Started.
Reflection is done.
Electricity is done. Okay. I'm so sorry. I didn't know this one. Did I start like? Okay. Yes. So it's okay. Any which ways. I think this will be easier, and then we can start with electricity. Then you'll be more prepared. All right. So where I was saying that we are doing one experiment part, which in school they do take you to experiment, right? They take you to do experiments, right? So this is the experiment that you will be doing, okay? And you will have experimental based questions also for that. So you will understand this more when you do it. But if we discuss now, then you'll be more careful when you're doing it in your class. You are given one glass slab. Okay, there is one glass slab, perfectly shaped rectangular glass slab, smooth surface. It is quite right. So this glass slab is given. Okay, what you do with this glass slab is you try to, you know that it is glass slab, it is optically denser medium. Okay, yes. All that they ask you to do is कि आप जो है refracted rays बताइए. If light is passing, तो path क्या होगा when it is passing through this glass slab? आपको ये दिखाना है refraction of light through this glass medium. Okay, so for that they give you one board. आप जिसके ऊपर पेपर एक आप white paper रखोगे, सारा अच्छे से place उस पे glass slab कर दिया है. So this is top view of that. So this is my white paper. I have kept my glass slab on that. All right. Okay. Then I choose any one point जहाँ से मैं अपनी ray को hit करने का सोच रही हूँ. ठीक है. So let's say मैंने ये point choose कर लिया. I name it as, let's say, N. Okay. Is this, there is Chintu, you're not able to see it? Okay. So I choose one point and that is the point. I draw incident ray. Okay. So I draw incident ray on that. I now very well know कि refraction के लिए मैं सीधा normal से तो ऐसे incident ray तो नहीं draw करूँगी. Why? Because I know the answer for that. It will go straight without any deviation, and they are asking me refraction. to show refraction of light. So I will choose one angle. So right. So let's say I choose one angle. I took 30 degrees. So let's say in this case I took angle I is 30 degrees. I choose this. This is the incident ray. This is drawn by me. Okay, I choose it. I draw it. So this is my incident ray. So how do I draw it? Because we can't see light now. हम तो light देख ही नहीं सकते. So how am I saying incident ray? So what we do is I draw one straight line, and for light also to follow the same path, I put two pins as a straight. दो pins होते हैं ना आपके pin board. ऐसे दो straight आप लगा दोगे. Touch नहीं बोले जाते हैं, क्या बोले जाते हैं, छोटे pins होते हैं ना straight pins. So I will place those two pins like this. So I'll put one pin on one, the other pin like this. So those two pins are kept like that, straight. Okay, straight like this. I have inserted. Okay. So those are there. Now what happens is, you know, like we all are in straight line. Okay. So I will only be able to see her if we are of same height. I will only be able to see her. Will I be able to see both of them who are behind her? No. Even if we are at any angle, but we all are facing each other, I will be able to only see her, the one who's right in front of me. जो पीछे है उनको देख पाऊंगी मैं, because we are all in what same path. So what we do over here is, what you are asked to do is, you get two pins, right? आपको दोनों pins को काफी straight रखते हो. They are exactly straight. जैसे आड़े टेढ़े भी नहीं रखने हैं. When you do that experiment, you will notice that you have to put it straight. Why आड़े टेढ़े नहीं रखने? Because अगर she is not straight और आड़ी टेढ़ी हो जाएगी, तो I can see the पीछे वाले person, right? So I have to ensure that they are all aligned in same direction or same path. So we keep those pins to very perfectly straight, perpendicular to the surface. Okay, and I observe the image of those pins from this side. Okay, and what will happen is, when I see the image of them, I will try to put the third pin such that when I put this third pin, ये सारे pins जो मुझे तीनों भी कैसे नजर आएंगे? अगर यहाँ पे let's say what is your name बेटा? खुशहाल है, नेहरा. Okay, ये जो है एक एंगल पे है. खुशहाल और नेहरा को छोड़ देते हैं. खुशहाल है, what is your name बेटा? तो खुशहाल है. Sorry, because I need an angle. So खुशहाल है, अनुज जो है यहाँ एक एंगल पे है. ठीक है, मैं ये साइड से इनका इमेज देखना चाहती हूँ. So then I see their image. Okay, but then I can see Anuj also, I see Kushal also. So what will I do? I will change my position such that I can only see Anuj and not Kushal, because then I will be what? Aligned properly. Okay, and then wherever I'm seeing only Anuj and not Kushal, I will place this pin such that now I can only see this pin and not Anuj. So what is this? What does that mean? That these three are what? Aligned. Okay, image of these three are aligned. So now I put those two pins here. Let's say I put that one pin here. So this is what? This is Kushal, this is Anuj. Okay, and we put one pin over here. What is your name? Arush. ये तो use हो गया. Arush. तो Arush surname क्या है? हाँ? What is it? P. Okay. You tell me later, because or else tell phone पे करना पड़ता है ना, P for what, like that. So it is P. So I have put P now, and then what is your name? So again, so Aryan P. So we'll take another. So like I have got three now. I will अभी यहाँ पे हमें पता है that कोई भी अगर line draw करनी है तो minimum कितने points चाहिए. तो यहाँ पे ये point तो मिल गया, but ये तो ऐसी कैसी line बनानी है. So I will need one more pin. So I will use B. Okay. So then again such that I will see only him, and ये pin लगा दिया तो I can't see him also. So all of those are alike. So this is my B. Okay. So I get this pin. Now I can remove my glass slab आराम से, and I can draw my. Okay, I am so sorry. I forgot to tell you one important thing. आप जैसे glass slab रखो, आप उसके boundaries trace कर लो. So this is my trace boundary, and glass slab ऊपर रखा हुआ है. ठीक है, आपने इंसिडेंट रे ड्रॉ कर दी है एंड अब आप ग्लास स्लैब जब निकाल लोगे आपके पास बाउंड्री तो है मीडियम का, ठीक है, आपके पास दो रेज भी है, ठीक है. व्हाट यू विल डू इज यू विल जॉइन दोस रे. नाउ आई हैव गॉट माय इंसिडेंट रे एंड मेरा ये फाइनल एमर्जिंग रे भी मिल जा रहा है, ठीक है. आई कॉल दिस एज एमर्जिंग रे बाहर जो निकल एंड आई सी दैट सिंस ये यहाँ पे हिट हुआ था तो ऑफ कोर्स दिस शुड हैव गॉन समथिंग लाइक दिस, ताकि यहाँ पे आपको ये मीडियम में तो उसका पाथ स्ट्रेट ही होना था. So I see through this thing, through this experiment, that this one when it is coming, it comes in this case it moves towards the normal, and then while coming out it is again what, away from the normal. My diagram is pathetic, but then this I was trying to do like this, so we'll redraw it. But all I'm trying to say is this is my incident ray. यहाँ पे refraction हुआ, let's say this is n और इसको हम m नाम दे देते हैं. So n क्या है, एक रिफ्रैक्शन है, फर्स्ट रिफ्रैक्टेड रे, एंड अगेन जब ये बाहर जा रही है तो अगेन देयर इज रिफ्रैक्शन, सो mb इज अनदर रिफ्रैक्टेड रे, ठीक है. So there is how many refraction happening? 2. From here it is what, air to glass, and here from glass to air. Okay. Since my diagram is not proper, what you'll see is that ये जितना आपका ये angle of incidence था I, और ये जब यहाँ पे मूव हुआ, यहाँ पे कुछ आर एंगल होगा, ठीक है, यहाँ पे कुछ आर एंगल होगा, और यहाँ का जो रिफ्रैक्टेड रे रहेगा, दिस आई and let's call this as emergent angle E. You will see that this angle and this angle are nearly what, same. Okay, and that is why you will see that if I extend this, they two will be what, parallel to each other. Okay, and I see that it has laterally shifted. Okay, to some extent, only that ray has laterally shifted. Everything else remains same. So it is laterally shifted by some, let's say, distance. Okay, so this is the perpendicular shift in my ray. I see perpendicular shift in my ray, and that is the whole experiment which tells refraction of light through rectangular glass slab. Okay. The two, so the question comes, mostly you have to do this, there is a skill required to do that. Mostly it's with respect to how you're placing your pins, how you're drawing emergent rays, and what you're doing. So mostly questions that comes is, what do you conclude from this experiment? Okay, so yeah. So we will redraw it. So I'm just placing it somewhere over here. So we'll redraw it, but what conclusions that we get is discussed, and precautions that we need to take while doing this experiment. Conclusion तो हमने थोड़ा बहुत देख लिया था, कुछ शिफ्ट हो रहा है, कुछ ये है, कुछ वो है, हम आगे डिटेल में पढ़ेंगे. प्रिकॉशंस क्या लेना है आप सोच कर बताइए. अगर हम ये एक्सपेरिमेंट कर रहे हैं तो मुझे क्या क्या प्रिकॉशंस लेना पड़ेगा? Can you go again? I don't know who's saying what. Can you be louder and clearer? Who's saying?
I said that we need to handle this carefully. Let's graduate properly, because sometimes these like images like a point or
we're not measuring and placing, we are seeing and placing the light.
Okay, so you're saying measurement.
Yes.
What measurement am I taking?
okay.
So pins. So she is saying pins जो है थोड़े दूर रखने पड़ेंगे. Pins एकदम पास नहीं रखते. So it's like when you're drawing a ray also, आप दो पास में रखोगे तो भी बहुत chances होते हैं proper करने के. So आप दो pins जो है दूर रखोगे. तो हमारे जो pins यहाँ जो खुशहाल है वो far है, quite far. So those pins like that. So that's the first important thing. Keep the pins at least they said some centimeters away, 3-4 centimeters, or even 5 centimeters is advised. So they say pins दूर रखिए. So ये हमारे A, B, and this is going, and then please use ruler to draw this because I'm not able to draw it properly. What did I name over here? AB है यहाँ x y x. Alright. So yeah, precaution one precaution is that आप जो है pins को दूर रखिए. Alright. What other things do you think can add to errors? But precautions के लिए ताकि गलतियाँ ना करें, error add ना हो जाए. What else?
Not the glass slab should run while we are.
Yes. So आप जब इसका मान लीजिए आपने एक पिन लगा दिया, फिर दूसरा पिन लगा रहे, ग्लास स्लैब गिर रहा है, तो अगेन आपका इंसिडेंट रे वगैरह ग्लास स्लैब को फिक्स रखें. What else? ये ग्लास स्लैब है, ठीक है? If this glass slab is not perfect, okay, they say air bubbles वगैरह या चिप्ड भी होते हैं, चिप्ड होते साइड से एडजस्ट से, तो भी प्रॉब्लम आ जाती है. Why? Because आप जब इमेज ये थिकनेस ऐसे रखा हुआ है, आप जब इमेज नोट करने की कोशिश करें, अगर आपका वो चिप्ड है तो इमेज की लोकेशन भी चेंज हो जाती है. ठीक है, तो रेक्टेंगुलर ग्लास स्लैब जो चूज करें, हाउ शुड दैट? इट शुड बी परफेक्टली स्मूथ, ओके, एंड नो बबल्स और नो व्हाट chips or anything. So edges should be smooth. The other thing or any other precautions that we should take. Pins is that like he said, what did you say? Glass slab should move while you're placing and putting pins on its places. And the other thing was sorry. That should be smooth without air bubbles. Okay, so these precautions will take. We'll make sure that those pins that are inserted are also what, straight. They are not like aage piche hara tera. We'll take that also precaution. Sorry? It should be aligned properly. Okay. That's your skill. Oh, all right. So that is our precaution part that we will take care of. The conclusion part that we'll start with is, what is the first conclusion that we saw? That हमारा जो ये एंगल था, एंगल ऑफ इंसिडेंस I, और ये जो बाहर का ये जो एमर्जेंट एंगल था, we also call that the final refracted angle, let's call it angle E. Okay, so ये हमारा जो एंगल I और एंगल E था, ये नियरली क्या था, इक्वल था, they are equal. Okay, so that's the first conclusion that we see, angle I is equal to angle E. First conclusion. What is the other conclusion that we see? Sorry. Yeah, refractive index is same. I did not get you. What is refractive index? It's like दो मीडियम के बीच का जो बेंडिंग रेशियो का वो, पर यहाँ पे तो मीडियम ही दो फिक्स ही है, तो लाइक सेम तो तब बोलो कि जब दो के बीच में कंपैरिजन हो रहा है. यहाँ पे पेयर ऑफ मीडियम तो सेम ही है ना, ग्लास एंड एयर ही है. सो लाइक ग्लास एंड एयर कंपेयर्ड टू वाटर एंड एयर, ऐसा कंपैरिजन हो सकता है. बट I did not get that point, but yeah, we say refraction of light. That we can say, yeah, we say refraction twice at point N and at point M. And we, how do we say that when light hits at point B, the ray moves where? So first thing we'll say that the refracted ray NM moves what, towards the normal? All right. And the second refracted ray, I'll just put it next to it. The other refracted ray, NY or MX, moves what? Away from normal. Okay, so that is the second conclusion that I make. What's the third conclusion I make is?
The emergent ray is parallel to the incident ray.
That's a very important thing. And what do we call that as? Lateral shift. So there is lateral shift. So we call this as lateral shift in incident and emergent ray. Any other? You can also add in this case that since it is moving from what, optically rarer to optically denser medium, it moves towards the normal, and if it is moving from optically denser to rarer, it moves away from the normal, which you already know. So from rarer to denser, it is towards the normal, and from denser to rarer, it is away from the normal. All right. Okay. So we can stop here. So there is lateral shift. There is okay. I want you to draw this properly using your scale so that you do not have such messy diagram. Name your glass slab something like PQRS. This is glass. Put conclusion. Put conclusion. And I'll see if we have some questions on this. There is a question related to this. Where is it? Can you tell? 39. Page 39. Question number 6. Page 39, question 6. Okay, yeah. A student has to trace path of ray to. Oh, great. For four different values of angle of incidence. All right. So we will discuss this. Okay. Draw this one and write 2 important precautions. We have discussed what 3 or 4 precautions and 2 conclusions. Okay. So in conclusions part, this is very important conclusion. Okay, this is very important. That emergent ray and this to an extent talks lateral shift. So this is very important conclusion. Angle I is incidence, and so this is emergent. If you want to put. Or instead I will just write emergent ray over here.
Precautions also we have to write.
Yes, note precautions also we'll discuss. So the major first important precaution is to make sure your glass slab is very smooth, without bubbles or chipped edges.
The next one is the pin should be aligned.
Pins should be away from each other, which helps in alignment. One change your mind now to celebrate. No. I would want to check everyone's diagram. Why are you using pen? What? About to check. Yes. Please ensure 2 things. ये एक एंगल पे हिट कर रहा है और यहाँ पे थोड़ा बेंड है, पूरा स्ट्रेट नहीं बना देना है, ठीक है? Yes, and one more precaution that we can put in precaution part, which I have to discuss. Finish it, but I'm just writing for me so that I can talk about this. extra pencil. And then extra blue tag is about data. They have to ask So, see, I was not able to, okay, please check here. So, even with this thing, I made sure that it थोड़ा बहुत तो मेरा जो इंसिडेंट रे है इमर्जेंट रे पैरेलल है, ठीक है? सो आपका तो प्रॉपर ही दिखना चाहिए. अगर ये आपने ऐसे ड्रॉ कर दिया है तो आप ये जब ये ड्रॉ कर रहे हैं तो आप इसको थोड़ा एक्सटेंड पहले से ही कर दीजिए और यहाँ से उसका पैरेलल वाला पार्ट ले लीजिए, ठीक है? अदरवाइज आप खुद से कुछ ऐसा ऐसा बना दोगे तो वो ऑलरेडी कैसा लग रहा है, पैरेलल नहीं दिखाई दे रहा है, ठीक है? Yours is not looking parallel, so you can probably extend first this one so that or else you can use protractor if you have time. Backbone you can always one thing, draw normal nature. I'm not able to see refracted angle. At least normal. Please draw two normals properly, okay? But you see, I'm not drawing normal from here to here. It should go thoda niche so that I'm able to show the refracted angle also. So थोड़ा नीचे तक आपका normal जाए, यहाँ पे भी आपका normal जाए, थोड़ा ऐसे. Name normal also, it's not that important, but we can call them N1 and N2. And these two normals will not overlap each other. These are at two different points. So why I'm saying this? You have put it 2 points. This is right. Show lateral shift and lateral shift.
Done, ma'am.
This is okay, Vedant and Aditya both are done. What about others? N1 and 2 increases incident rate. Where is your incident rate? No points or no pins. All right. diagrams are done, I will take a quick look at that. Please ensure that your incident ray and your emergent ray are parallel to each other, because that's the whole thing. There is lateral shift. So if this is going like this, first draw this incident ray, aage trace out kar lo, and place that ruler only and go like this and try to find out, because you are not doing experiment. So experiment क्यों नहीं करते तो आपको सब वही आ जाना था, but you are trying to re-put everything which is going to be given by experiment. Okay. Show me what is happening. Okay, so that's what I was saying. See, there is lateral shift nahi hai, isko lateral shift nahi hai. I'll tell you where exactly. ये इंसिडेंट एंगल आपका नॉर्मल केस हो जाएगा, आपको ऐसा चलेगा। You know, I explained it. Give me scale. Please, you know, I did it. Things that you have to ensure is आपका normal है, perpendicular to the surface of the normal one है. Draw the ray, okay, split points. Then draw your one. This thing, you have the incident ray. सीधा parallel यहाँ पे draw कर दो. ठीक है, ये कैसे draw करें? Towards the end, 15 minutes break that will have to. Why 10? I saw yours. What I have done, I saw yours. Looks perfect. थोड़ा लग रहा है मुझको तेरा, पर यहाँ से है. Just check. It seems. Give me scale. Give बड़ा. अब ये अगर ये स्टेटमेंट कैसे? All right, I think I've checked yours. Yes. Fine. All right, so let's, one other precaution that is to be seen is we take angle of incidence in this range between 30 to 60. The reason being, आप बहुत कम ले लोगे तो आपको वो बहुत क्लोजर चला जाएगा, और आप बहुत ज्यादा ले लोगे तो emergent ray जो है यहाँ से बाहर निकल जाएगा ये surface से, और या तो फिर आपको ये edge के around दिक्कत आ सकती है image formation के लिए. So as a precautionary measure आपको बोलते हैं कि आप 30 से 60 डिग्री के बीच में ले लीजिए incident angle. So yeah, and there was one question. Page 39 you said, right? Page 39 what? Question 6. So there is one question which says a student has to trace the path of ray passing through a rectangular slab for 4 different values of angle of incidence. The question is, student has to do this experiment, but for how many angle of incidence? 4 different values. So ऐसे 4 अलग-अलग ray में बनाऊंगी with different angle of incidence. And I'm sorry, through that they say write the 2 important precautions for this experiment. So we already saw the very important precaution that we see is our glass surface is like glass slab is what? perfectly smooth without bubbles or without chipped edges. And the second one was what? 2 pins at least kept 5 centimeter, 4 centimeters away. The third one was what?
Glass cover.
While tracing or looking at the images, but the glass slab should be fixed, it should not move. And so that is precaution part. List 2 conclusions that the student draw from this experiment. So in this case, he is drawing 4 different angles. Okay, for 4 different angle of incidence, he is going to do this experiment. What do you think will he conclude? Of course, he'll have these things that for each case, his angle I and angle E will be what? Equal. Okay. And of course, again, there will be lateral shift and incident and emergent ray and this. So we will have, you can take any 2 of this. And what else can you see if he is drawing 4 rays over there?
The higher the angle of incidence, the lower would the lateral shift be. And the higher the angle of incidence, the lower the lateral shift.
All right. So he's trying to say that if this is, I drew it like this, but if I have drawn my angle of if this is my angle of incidence, then there will be some shift. And then my parallel ray would be like this. So parallel this and this, there will be some shift in incident ray and parallel ray. So what are you trying to say in that?
I'm trying to say that the higher the angle of incidence is, the lower is the, like, if it's 90 degree, then there's no shift. If it's
Yes.
70 degree, there's a bit, then it's a bit more. So like the lower the angle, the higher the shift.
Okay. Okay. I think what he's trying to say, I'm just trying to clarify by showing you 2 diagrams. Do you mean that or something else? If I have your book and your book, are you trying to say that this angle is on which the shift basically
Yes,
lateral?
because it's closer to the north. This
Okay, so what? So yes, so what he is trying to say that when you're closer to the normal, basically when your angle I is lesser, then your this will be even more lesser refracted ray, and that is why the shift, the lateral shift will be very closer to. I'll read about this what he's trying to say. You might put that, but then we have other important conclusion which should be put, and we cannot miss these important points, but we can add that. No, that's correct.
yes, I was saying it because he's given 4 different patterns.
Yes. So what? If this is my angle of I, there will be the refracted angle will be even more closer. Okay, and what he's trying to say that when then this comes out, then the shift over here will be very less compared to what it would have been when the angle would have been higher. I think that is what you're trying to say. Okay, so that shift we can put that as well because we are using what 4 different angle of incident in this case. But in all those cases we will see that our incident ray and emergent ray are always parallel to each other. That is why there is lateral shift. And in all of those cases, we'll see that the angle of incidence and angle of emergence is same. Okay? And this, of course, we see in all the cases that when our incident ray is hitting the glass medium, it will move towards the normal, and when it is moving out of the medium, it will move away from the normal. So we can put the same conclusion over there. That's nothing to worry about that. But if you are putting anything extra, make sure you put it in very clear, crisp word. Put it as extra. Put the main points as well, but put the others if you want as extras. Okay. If they're asking for 2, you can put more as well. Let me see if we have some other questions also. All right, we have one interesting question. I would like you to solve that. And then I think we can start with lenses. Okay, so this is a very important question. Page 42, question 37. And I don't think so we have any more questions with respect to the glass line experiment. Page 42, question 37. Whose book is this? Yours? Not this one. Okay, what is the time? We have 5 minutes. I think we can do this in 5 minutes. Question 37. I think it has refractive index of water and glass given, and you have to solve that. You read the question for us. I think you are not aware because you have
The
missed it.
refractive indices of glass and water with respect to air is 3 by 2 and 4 by 3 respectively.
Okay, let's go slow by slow. So what is the refractive index of what? Glass
Glass is 3 by 2.
is 3 by 2. And
Water is 4 by 3.
4 by 3. And they said that both of these are with respect to air, right? All right. What else?
Speed of light in glass is 2 into 10 raised to 8.
Speed of light in
Glass
glass. So V in glass.
2 into 10 raised to 8 meter per second.
All right.
And find the speed of light in water.
Find the speed of light in
Water.
water. We need to find. Yes. The first thing that comes to your mind is we'll use formula related to velocity. What is the formula? For NGA, what is the formula? Yeah, speed of light.
The speed of light of what?
Speed of light in what? ऊपर नीचे जहाँ दोनों जगह पे स्पीड ऑफ लाइट ही है, हम लाइटिंग के साथ तो खेल रहे हैं. Speed of light in air. हाँ, ऊपर क्या है? Speed of light in air. उसको मैं C भी लिख सकती हूँ. और नीचे क्या है? Speed of light in ये एक फॉर्मूला हो गया. दूसरा फॉर्मूला क्या है? NWA. अभी बताइए, चलो आप बताओ इसका फॉर्मूला क्या है?
Speed of light in water.
ऊपर it's the same thing.
Air.
Yeah, it's again speed of light in air and
Upon speed of light in water.
yes, speed of light in water. Okay. We have what? I know this. I know this. I know this. I want this. Okay. Right? And I have this formula. What I will do is I will name this as 1, this as 2. I know this C is common in this thing. Right? If I divide this by this, divide 1 by 2, these two will get cancelled. Are you ready? What I'm trying to say? No? Okay. So divide 1 by 2. ये first equation है, ये second equation है. हम दोनों को divide कर लेंगे. ठीक है? So ये यहाँ पे LHS का division कैसे नजर आएगा? NGA upon NWA. Is this okay? अब ये साइड का डिवीजन कैसे होगा? C upon BG divided by C upon BW. ठीक है? इसको प्रॉपर्ली लिखेंगे तो कैसे लिखा जाता है? This upon this, ये डिनोमिनेटर है. Upon C था, so this is C upon BW. This is how I will rewrite it. Okay? I see this gets cancelled. I have 4 values. I want this. What is VW? VW is equal to NG by NW also multiplied by VG. Give me the answer quickly.
Around 2.25 to 10 raised to
2.25 is that the answer for others as well? Please check. I hope this part is clear. You would be doing this in algebra all the time. You know, dividing 1 by 2.
yes, it's very clear.
Sorry.
But there's no need to do that.
Yes, there's no need to do this. We can take the shortcut as well, because what is the thing? We already know it is dependent on what? Velocity, and we have common medium, and the your textbook has given a shortcut formula for that. Then how are you saying?
I'm just saying that we can just do it normally because we know 3, like if we just write the second formula, we can solve it normally also.
Normally you can put value here, substitute there, and then take
Ma'am, like this 4 by 3 is equal to C value, we know 3 into 10 raised to 8.
Okay. So he is saying that you take C value because you know C value. Okay. But this, in this case, while I have shown this case, they were very sweet to you that they gave you air as the medium. So you knew air का value, you could have put 3 to 10 to the power and 3 to 10 to the power. So आप उस तरीके से भी कर लेते, but I would not suggest you to go that way, because the same question they can give you and then they say n of g, instead of saying with respect to air, they will say this is with respect to some other medium. Let's call it what? Air, water हो गया, और कौन सा medium? Kerosene ले ले, ठीक है चलो. So this is Ng is 3 by 2, Nw is 4 by 3. तो यहाँ पे आपका ये जो K आ जाता, so ये हो जाता Vk. क्या आपको Vk की वैल्यू पता थी? नहीं पता थी, फिर भी आपको तो ये सॉल्व करके आंसर मिल सकता है, राइट? क्यों? क्योंकि अंत में Vk तो कैंसिल ही होना था, ठीक है? So I will not suggest you to put value C का directly until you are specifying it, ठीक है? और until there is dire need आपको कुछ और भी उस टाइम सोच नहीं रहा. Otherwise, this is the way you should go about, because not every time they will be that sweet that they will give you the second medium as air. Okay, so that you presume that you take it to 10 to the power. They can give some other medium as well. Is this clear?
Yes.
So we can take break. For the next part, we will be doing complete ray diagram. So I would want you to have, if you do not have pencils or not having anything, please get it ready, because next 2 sessions will be complete ray diagrams. Okay, we will be doing full-on ray diagrams with lenses and everything. All right. Thank you so much. See you after 15 minutes. Vedant and Aditya,
Yes,
I
ma'am.
Yes,
was
ma'am.
not able to see your diagrams of the glass tap. Can you show it so that? in
Yes,
case
ma'am.
we- Okay. Vedant, your Amazon tray and that is traveling so good. Aditya, can you bring yours closer, because all right, Aditya, yours also seems parallel. Okay, thank you. See you after 15 minutes. All right, so
We have to start the video.
I have to start what?
Video.
All right. Yes, so we'll begin with lenses now. Okay. And in the last 1 hour, like the last hour, just remind me that I have to give you one question with respect to rectangular slab. Just remind me, I need to give you that question. It's pretty important. Yes, so let's begin now. Let's start with lens. It's appropriate to say good morning to you. Okay. All right. So we are starting new topic now. So we are starting lens now, and like we did in mirrors, now we will be checking using lens how we find images. Where do we find images? How are the images found? Okay. Right. So now, like mirrors, we started with what? Plane mirrors, then we moved to spherical mirrors. In this case, now we are doing refraction, and in refraction we saw for a rectangular glass slab what happens, okay? How the rays move and what are the laws of refraction and all. Again, in this case, we will see that if we take these refractive optical medium, if we take this medium in spherical shapes, how does that affect the bending of rays and how are the images formed? Where are the images formed? We will do the same. Okay. In this case, again, we are having some curved shapes. There is curved shape over here. Okay. If let's call this. Okay, I want somebody. You can answer this question. If this was the mirror, what do I call this mirror? What? Concave. This is what?
Convex.
This is convex, and this is what?
Concave.
Yes, yeah, this is convex, and there is cave inside. Like, and please do not get confused. You are confused here. I don't know what will happen when you come here. So this is convex. This is concave. This is which lens now? We call this as convex.
Convex lens.
And this is which lens? Concave lens. All right, so this is the nomenclature parts for easy. Okay. Now this we see that these are two curved shapes. These are two curves. This is also circular curve. This is also curve, spherical curve. To be very precise. So these two curves actually these are double convex lens, and this is double concave because there are two concave sides. Okay, but in general, whenever the two when the medium is bounded by two curved surfaces, and they are what in this case it is bulging outwards, and in this case it is inwards. Okay, so when it is bounded by two outward bulging curves, we call it double convex lens or convex lens. So whenever we are in general referring convex lens, then we mean double convex lens. Okay, and whenever we are using only concave lens, we mean double concave lens. Are you getting what I'm trying to say? Because there are various lenses where one side is plane and other one is concave. So plane or concave lens. Okay, and one would be plane, other one would be convex or plane or convex lens. Okay, so there are different kind of lenses depending upon how like what kind of shape it is, and whenever there is double bulging outwards surfaces, curved surfaces, we call it double convex lens or convex lens. And whenever they are they are bent inwards and the curve is bent inwards. We call it double concave lens or concave lens. So the interesting thing when it comes to this and this is most of the students start comparing, and in that comparison there is a lot of confusion that is created. So I will be drawing this at like together so that it is very clear. So in this case, when we talk about mirrors, we straight away come to one thing is focus. Okay, and how do we find focus of any mirror? What do we do in that case? Can somebody tell me? Like, how was even focus defined? What kind of rays?
The parallel rays.
So we will hit them with parallel rays, and wherever they are meeting, I will call that point as focus point. So when we hit our convex lens with parallel stream of rays, since this is not a mirror and a lens, like a refractive medium, optical medium, rays will pass through it, right? So I do not have to reflect and rays will pass through it. But this particular shape will ensure that when it passes through it, they come together at one point, okay? And I will call this point as what?
Focus.
Okay, this is my convex lens. And you remember when rays come together, what is the word that we use?
Converge.
Yes, the word converge. So in case of lenses, when I say converging lens, we actually mean which lens? Convex lens. But what happens in case of convex mirror? So what is the other name for convex mirror? So in this case, rays will what? Move away from each other, and it will appear that they are hitting somewhere else. So that is diverging mirror. Now again, I have to find focus of this particular lens, which is who else is remaining?
Everyone.
Okay. So then again, what will happen when it is hitting my concave lens? So when it is hitting my concave lens, the rays, in this case they diverge, and in this case, sorry. Okay, sorry. So in this case they converge, and in this case they will diverge, and we see that when we extend them backwards, it seems that they are all coming from one point, which we call as focus. Okay. So in case of convex lens, we call them converging lens, and in case of concave lens, we call them diverging lens. Okay. Now you will tell me, we know sign convention, right? We know sign convention. For convex lens, focus is what? Positive or negative?
Positive.
And for concave lens, focus is what?
Negative.
Okay. And in this case, all right. Do you want to draw this, or this is clear? This is clear because individuals will be drawing many diagrams. For this, so now we have to start with ray diagrams, and like for ray diagrams, we need to know various points. Since this is, we'll start with which lens is this?
Convex.
So we'll start with convex lens, and I'll start defining the points. So this lens is part of one sphere, okay? And what is the center of sphere called?
Center of curvature.
So I will call this as C1, let's say. Okay, so the center of curvature of this would be, let's say, C. So there would be another on this side as well.
Yes.
Right?
Yes, sir.
Right? So there will be like two center of curvatures in this case. And when I'm hitting rays from this end, where will be my focus? On that side. So let's say there is focus somewhere here. Okay. But what if I'm putting rays from this side? Where is my focus found?
This side.
What do I see? In this case, how many focus do I have? So there are foci, two foci. One is this side, one is that side. So I'll be naming why two. Now this is clear. So I have two focus as well over here. And the very important thing is the center of my lens. What do I call this as? Pole is in which case? Mirror. In this case, I call it as optical center of lens. What do I call it?
Optical center.
That's the difference which you have to remember while diagrams also, because they mostly ask you to define what is pole and what is optical center. There shouldn't be any confusion over here. Pole is for what? Curved mirrors, and optical center is for what? Lens. Okay. Okay. So this is the center of the lens, and there is a way to define it. We'll come to that. We're coming to that. So now, for any ray diagrams, I need one main axis. What do I call that axis? Principal axis. So that axis is passing through what? Over the center of curvature. So this is my principal axis. I got my principal axis. I have two focus, and now I don't talk about center of curvature, okay? Because throughout your chapter, you see that we are using what? We are using small aperture lens, okay? They use small aperture word, okay? What is aperture? Whenever these cameras or whatever you are using, the amount of rays of light that is going through lens, it depends, you know, if you close them to a black flap, जब थोड़ा कम हो जाता है, बढ़ता है. So वो आपका क्या कर रहा है? Aperture कम ज़्यादा कर रहा है. Aperture is the surface area basically, जिसपे light जहाँ से पास हो रही है, कितने एरिया वो डिफाइन करता है. आपका एपर्चर डायमीटर के टर्म में, अगर मेरा एपर्चर लाइक दिस इज माय कैमरा और यहाँ का जो मेरा लेंस इतना होता है, ओके. सो एपर्चर कितना है, उसका वो जो डायमीटर है वो एपर्चर डिफाइन करेगा. द एरिया बेसिकली इज डिफाइंड विद द हेल्प ऑफ डायमीटर. डायमीटर बड़ा है तो एपर्चर बड़ा है, डायमीटर कम है तो एपर्चर कम है. बट वेयर स्टूडेंट्स गेट कंफ्यूज्ड इज दे कंपेयर दिस एपर्चर विद रिस्पेक्ट टू, when we talk about diameter of this aperture, they confuse that with diameter of the curvature of which this lens is part. No. We are not talking about that aperture. This can be part of some huge mirror, ठीक है? But then this is one छोटा सा, इसको आप ऐसे व्यू कर रहे हैं, और अगर मैं ऐसे व्यू करूँगा तो इतना छोटा सा होगा. ये जो लेंथ है मिरर का, ये लेंथ, मैं उसको aperture बोल रही हूँ. Are you getting what I'm trying to visualize in this diagram? Okay, so we are using small aperture lens, okay, and now we will be using, so let's say this was the focus that I got, so I named this side as f1, this as f2, and I take 2f also, double of the focal length. What is focal length? How do I define focal length? Focal length. Not pole, okay? In this case, I'll say distance between focus and optical center, okay? So that is my focal length, and 2f is what? Double of my focal length. On this side also, I'll put 2f. This is clear, okay? Now, why are we doing all these things? Because we need to find what? Image of the object, where it is formed. We are doing all these things for that. So for mirrors, we had like 4 kind of rays that we used. Out of those 4, we had used any 2. For these, we have 3. It's very easy actually. For this one, ray diagrams is pretty easy. So let's see which is the first one. So the first one is when the very first thing is similar to what happens in our mirror case. The ray is hitting in what manner? Parallel manner. Okay, so ray is hitting parallelly. What will happen after refraction? It will pass through what? Focus. There are 2 focus here and here. Which focus shall I pass it through? That one, because this is not mirror, so it will not reflect. It will pass through, but such that now it is passing through. Let's call this my focus. Okay. This is the first one. So it passes through focus. The ray is parallel. After refraction, it passes through focus. The second one is The second one is it passes through optical center and goes without deviation. So it just passes. In case you do not say it traces back, because there is no tracing back. This is what? Lens. Nothing is going to come back. So we just say it passes through O and goes without deviation. Without deviation in the sense without any bending. So if it is passing through O, it will go without, I have not drawn properly. Let me draw it. So let's say this is my optical center. It goes without any deviation. This part is very important because this is how you will define what is optical center of a lens. So what is optical center of a lens? Optical center is the center point of the lens from which ray passes without any deviation. This is how you will define it. So that's very important point. Because that is definition of optical center, that ray will pass without any deviation. Okay. Now the third one is what? It will pass through focus. Now in this case, this is done. इसी का उल्टा जो हम पहले में करते थे, इसको मैं third कर सकती हूँ. So what is the second one? It passes through focus, and after that, that is parallel. So in this case, this is my focus, and after that, it will be what? Parallel. Okay. So these are my three rays. Very important. Okay. You can either write this if you want to draw the diagram. You can draw that because now we will be starting the ray diagrams for all different positions. And now you know where, how you have to make sure that you're not going wrong. So is this clear? Three rays. Shall I start? So take the first question. We are starting with. All right. All right. This is three rays, right? What kind of lens have I used? Can you show me the three rays for the other lens? Because the rule will be same, right? So in your book, you draw these three rays for concave lens. Did you get my question? So let's say this is my optical center. I don't want image formation. I just want to see how these three rays will look when it is following its path in concave lens. Show me the first one, parallel focus. Show me that. Show me the first one. Keep your object anywhere, it doesn't matter. I just want to see what is happening. So first one is what? Parallel. So ray is parallel. Show me what will happen after we follow this first case. Okay. So the rule says when it is parallel, it will pass through focus. But this lens is what kind of lens? Okay. And I know that it cannot bend towards the focus because it is diverging. So, but how is the bend in the upward direction? It's defined that it should appear that it is passing through what? Focus. So show via dotted lines that it is passing through focus. This is my first ray that I will be using for image formation. Is this clear? Can I quickly come and check everyone's views? The second one and third one becomes easier now because in this case, the second and third one becomes easier. O is always easier because the last one it goes without any indication, right? And the next one where the ray is passing through this, that is, I do not have to worry because it becomes parallel. So the only one, first one is important. When it is parallel, it diverges and I have to show that it is coming towards the focus. I will start with ray diagrams. See. All right. So first one, object. We always keep object. We started with what? Object is kept at what? Infinity. So the first one where object is at infinity, rays will hit in which manner? When object is at infinity, rays will hit in which manner? Parallelly. I don't have to show the image because I don't have to show the object because object is at infinity, so I cannot show it over here. So object is at infinity, they will hit parallelly and it will meet at one point. So image is formed at which point?
Focus.
And what is the type of image? Real and is it enlarged or diminished? So
Diminished.
diminished. So this one we can skip or this one we can skip, right? So we'll move to the second one now. So the thing was as we are bringing object closer. So this was infinity. Now we'll bring our object this is my optical center, this is my F1, this is my 2F1, this is my F2, this is my 2F2. And now I'm bringing my object slightly closer now. I am not at infinity, but I'm bringing it closer. So it is somewhere beyond 2F. My object is beyond 2F. Now for this, please show me the image location with your ray diagram. Use any two rays, preferably the parallel and focus and the optical center, because that goes without deviation. You can use it. Show me the image location. And keep this table side with the next page so that you can fill it as you are drawing your ray diagrams.
Start the second
Yes, the last one. This one, this one. So yes. Ray will pass through what? Did I say focus or double of focus? And focus, it will pass through. When we are doing this picture, inaccuracy. This is focus your language. It is not accurate. Why? 0 to length of please ensure your measurements are very accurate. I'm coming, okay? Please ensure that your measurements are very accurate. If this is 2 centimeters, this has to be 2 centimeters. Like this is all we have already worked on these things. So where is your image forming? Which is between F and 2. Yeah, between. All right, all right. Can you comment on the image and draw the image also? Now you know where is the image forming. Draw image also, everyone. Okay, what's still drawing? Yes, so image one. So draw the image also now. Good. So I think most of you have got image location. Image location is what? Since now first image was what? At F. जब आप नजदीक ला रहे हो, image दूर जाने वाला है, तो image will be between F2 and 2F2. Okay. And what is the image? What can we talk about image? It is again real and it is slightly diminished, but it is diminished. This is highly diminished. This is diminished. We can say it is chota. So I think you all would have done this one this ray, and the other ray was what?
Optical.
So this is my point where it is meeting, and it is between F and 2F. So even with my rough diagram also it is coming here. So I hope everybody has got it between F2 and 2F2. Yes. What about Vedant and Aditya?
Yes, ma'am.
All right. नहीं एक रे जा रही है यहाँ पे, इसका बनाओ पहले कहाँ जाएगा, इसका बनाओ अब right in front of me, इससे पास होगी और नेक्स्ट रे कहाँ जा रही है, सीधा ऑप्टिकल से लेवल से, और कैसे जाती है, ऐसे ही पास होगी This is your water. We can point of the direction. We will come out from it never passes through too much too. Next time, somebody will give him sharpness. I think he is not from this one. Yeah, I'm coming. ये किसका टिप का इमेज था ना, नीचे नीचे ये पॉइंट था टिप का सिर्फ नीचे What is near to F and it can be anywhere between F2 and 2F. Okay, I'm sorry. आपका बीच में है ना, तो ठीक है. सबका अलग क्यों होगा? Because इनका डिस्टेंस देखिए इतना है. आपने शायद थोड़ा दूर रखा हुआ है, थोड़ा करीब है. तो शायद अच्छा ही होगा. Yeah, that. So this yes, Vedant and Aditya, can I quickly take a glance? All right. Yes. Okay. What will happen if I think that if there are already only 4 people, only 1 person, right? Then I want to. All right. Yes. So this one is done, and I think we all got the answers, and now we already know what will happen as we are moving closer. अभी beyond 2F पे तब मेरा ऑब्जेक्ट कहाँ जाने वाला है? 2F पे, ठीक है? और यहाँ के लॉजिक से भी हमें पता है कि ये अभी जो है इमेज जो है कहाँ जाने वाली है और दूर जाने वाली है. अब यहाँ से पहले फोकस थी, अब बीच में आ गई, अब कहाँ आएगी? 2F पे ही आनी चाहिए आंसर. आपका काम डायग्राम बनाते टाइम ध्यान दीजिए, आपको आंसर तो ऑलरेडी पता है. But that doesn't mean you mess up and try to put it there. Make sure it gives you automatically. So now. And this is F, this is 2F, this is again F2, F1, F1, this is 2, F2. My object is at 2F. Yes, will you draw it? Yes. Now draw it again. at 12:45.
Yes.
So, so you already know the answer. I hope. So my diagram is not that correct, but wherever your image is forming, it should be 2F. Yes. Let me see quickly. It is done. Just click here. थोड़ा और आगे जाके देखो, पता ना मैं why this is why arrow upwards? So it is at 2F, and again it is real, and this is very important. What can you comment on the height of the image? Same height. Okay, it is same height. So I believe most of you are done. Where is the image from? This is the second one. You can't do anything like this. This I have told you is just for land up to it to se खींचकर image का सब तेरा बना सकते हैं. आपका image नहीं बनना चाहिए. नहीं बना रहने में कुछ दिक्कत हुई ना तो गलत हुआ. So let me see where it is from. Please ensure you do not take such rulers during examination. Nothing is visible when it's certificate.
Excuse me, ma'am.
Yeah.
Ma'am, the image is formed at 2F2, not 2F.
Yes, it is at 2F2.
But
You also
ma'am, yes, ma'am, but in the table you have written 2F.
it is at 2F2. So actually in your table also I think textbook also do not mention what is F1 or F2. It is understood it is on the other side, because in this case I'm keeping my object this side, but if my object is this side then the image will be formed on that side. So that is the reason they just put it like this. But in this case we will keep it like this. Yes, I see certainly your dimensions measurements are inaccurate. इसके बीच का अंतर जो है ना इतना ही होना चाहिए, पर वो तो ज्यादा नहीं होगा. तो आप यहाँ पे इसलिए ऐसे नहीं कर सकता. Why you are going to understand the first basic step? ये जितना ही होगा. Do not go wrong. Double ना, is double of F1. So the F1 also. Easily go ahead. I can't even ask you to erase it. So when you will erase the time, redraw it. Measurements should be accurate. Like I am again and again stressing, these measurements should be equal. Like if this is 2 centimeter, itna hi 2 centimeter yahan. All right, the ones who are done can go to the third one. Now we will move one step closer. अब मेरा object आ जाएगा 2F और F के बीच में. Let's put like this. So my object has gone even closer now. that's where you're going wrong. You cannot ऐसे ही मतलब आप ये ना अंदाजा भी लगा रहे मेरे को रूलर ही नहीं उतना बड़ा ना बेटा मेरे पास तो नहीं इसलिए मैं जैसे ऐसे हाथों से कर रही हूँ आपके पास रूलर है ना आप ये यूज करो तो देखो कितना लिया उतना ही डबल ले लेगा can somebody give him another ruler change your ruler I will really suggest you आपके चश्मे already है बहुत difficult can somebody give one ruler if you have extra only one all right so we will if someone is done please lend a ruler over here okay? Common marker है बना आप बेटे मेजर करो इसको थोड़े दूसरे देखो this is what is third one no this is the second one oh what about the third one let me just put it on. So now I am moving my object even closer the object yes okay so now my object is where it is between object has been brought even closer f2 to f2 you're done like give your ruler to give your ruler take this one take proper 3 centimeter लेना तो next 3 ले लो लेना तो there is my image form already it is certainly done okay it is at last so yes Alright, so I see that everybody has got it. What? Where is my image now? Beyond 2F and how does my image look? Is it real? Yes, it is real and it is enlarged. Now let's move to the next one. Now my object is at what? Focus. Draw object at focus. You're done marking, right? You can give them the for drawing meant you can use your scale. So marking के लिए आपको scale. ठीक है. So now we are moving our object at what? Focus. जब फोकस पे ऑब्जेक्ट चला गया है तो एग्जैक्टली उल्टा होगा जब इंफिनिटी पे था तो फोकस पे बना इमेज ऑब्जेक्ट इज एट फोकस तो इंफिनिटी में हमारा इमेज होगा Are you done? I think he is using very good trick, but then he's carrying protractor. So I would share his trick. The ones who are You can use this protractor to draw your lens at least in the shape में तो lens ले करेगा तो you take this side आपका आधा बना दीजिए यहाँ से and then take ऐसे ही उल्टा आधा बना दीजिए so it looks kind of good ray diagram. Yeah, it looks what is that? What is this? Optical center is not because it is moving without any deviation to F also. F also all right. Some inaccuracy because they would have said plus working otherwise like what so let's see what that. So you should get two parallel lines, right? So you need to get two parallel lines. So आपकी first जो है parallel ज्यादा focus से पास हो रही है और दूसरी जो है आपकी optical ray ये दोनों parallel दिखनी चाहिए. So this is the other ray, and then you just say that object image will be formed at what infinity wherever whenever they meet it will be formed. And what will be formed for yes actually yes so what is happening I just missed out this fact most of the children who are drawing here वो आपके arrow की direction डालना भूल जा रहे हैं please show the arrow direction as well make it a complete ray diagram do not miss these nuances and yes so now tell me what will you comment on this is infinity. What kind of image is it?
Highly magnified.
Yeah, it is highly magnified. And is it real? Yes, we'll call it real. Whenever they will meet, they will form a highly magnified image. All right? ये आपको ऑप्टिकल सेंटर से पास नहीं हो रहा हाँ यहाँ मैं लगा सही तो मगर बात पेन से क्यों लगा है all right I think we will move to the final one we'll go even more closer between optical center and my focus Vedant and Aditya I am so sorry I just missed. Can you show me all the ray diagrams now? Chalo jaldi. The others can start with this, okay? O and F1. Okay, wait now. I think for these I have to. Forward this. Not help me. I think spotlight. Okay. Okay, wait. So this one is okay. Aditya, can you put it थोड़ा और ऊपर, like आपकी book थोड़ा और ऊपर करो, मुझे ऊपर. हाँ बस. ठीक है, parallel देते हैं. Vedant, can you show it now? Aditya, you're done. All right, good. Yeah, good. Go for the last one. Now we are moving our object even more closer. The ones who are not done, it's okay. We will go slowly for it. The ones who are done, go ahead. Which one? Where are you? What are you doing? Parallel.
Yes.
Okay. Good. This is very good. Let's show that. So this was what focus. Highly magnified. So that is highly magnified. See this. it, so they are clearly divergent. Expand, you can see that it is divergent. It's something like that. I just get now. All right. So now the last one. When you are keeping it as much close as you can, and you check where is the image formation F2 to F2, and yes, so give me and this achievement, like we should give you which will actually take the same measurement of F1, F4. Why is this so wrong? What's the although it is of no use, but then don't mark it only. So did this, draw this image right now properly. Try to do it. So this is that is clear convergence, but I think how clear to see कहाँ मिलती है शायद मिल जाएगी हाँ बेटा ऑप्टिकल से so keep it and allow it of course it is incorrect. But then I'm saying that I'm allowing it because after starting, थोड़ा देर में shift कर देंगे करना पड़ेगा. So that is the reason to take out the mistakes after the investment of the यहाँ पे जो एक तो बनने वाली and if you want to redraw it, but then use protractor, try to check accurately how it is one diagram you can do that. Because this one is the last one. Yeah, meeting point to draw proper and show you where it is meeting and draw the image. I think everybody is. Yes, I'll just come. So in this case, what is going to happen is when it is parallel, it will pass through focus, and the other one is it will pass through optical center. And in my diagram, it does look parallel, but it will be slightly converging. और आप वो पीछे जब extend करोगे, आप जब पीछे वो extend करोगे, it will meet certainly somewhere, and you have to draw image over there. And yes, so who was check there. Extend for each. This is what? And the most yes. Meeting point like ठीक है आपका मीटिंग पॉइंट कहाँ है all right so after so where is the meeting point for everybody between f and 2f और किसी का कहीं और अलग जगह पे आ रहा है beyond 2f आ रहा है ठीक है और किसी का कुछ अलग आ रहा है
between F1 and O.
here between f1 and 2f ना
No, F1 and O.
f1 and o आ रहा है आपको
Yes.
ओके आपका ऑब्जेक्टिव उधर है पर ना
Yes.
all right so what I'm trying to say is it's okay wherever you are getting that's not the reason to worry आपका जो ऑब्जेक्ट है उसके डेफिनेटली बियॉन्ड ही जाने वाला है ठीक है and this is like we discussed or we haven't discussed so since these are the rays and ये हम क्या कर रहे हैं trace back कर रहे हैं so we are just when we look from here we see that oh actually they are coming from somewhere behind the lens on this part so we call such image as what virtual and it is what magnified and virtual and image is what हमारा यहाँ पे जो हमारा बियॉन्ड फोकस जा रहा है ये है सो दैट्स ओके यू डोंट हैव टू वरी फॉर दैट I think we are done with all the ray diagrams. Let me discuss some questions which are everybody is done with all these diagrams. Please let me know. We have to take one question. So this is clear, यहाँ पे?
Yes.
Can somebody see where is this question because my book number and this book number is different. A question goes like this: a student focuses image of candle flame placed at about 2 meters from convex lens. A question like this. See where is it on your book? Okay, I think I got this. It's page 41, question 31. Whose book is this? You have any book? No, right? You take this. Yours. You both can share. All right. So the question is, page 41, question 31. A student focuses.
Student focuses the image of candle flame placed about 2 meters from convex lens. focal length 10 centimeter on the screen. After that, he moves gradually the flame towards the lens and each time focuses its image on the screen. In which direction does he move the lens to focus the flame on screen? What happens to size of image of the flame formed on the screen? What difference is seen in the intensity of image of flame on the screen? What is seen on the screen when the flame is very close at about 5 centimeter to lens?
Okay, so we'll start with the first question, but let's depict the question first through ray diagram. So how will you draw? There is a convex lens, and in earlier case, object was kept where 2 meter. So show me that depiction in your diagram. Focal length of that lens is what? How much? 10 centimeter. This is optical center. This is my focus. This is how much? 10 centimeter. Where is my object? Here. किधर है मेरा object? मेरी object किधर है? 2 meter. So quite far. Very far, I would say. Earlier it was at 2 meter. It is in meters, okay?
Rough diagram.
No, just rough diagram because I am depicting it just to see the scenario. The question is, then he saying that he gradually moves flame towards the lens, and we know as we move toward the lens, what happens to the image, right? As we are moving towards the lens. So he is saying that he is moving towards the lens. In which, the question is very interesting. In which direction he moves the lens to focus the flame on screen? So, आप ये 2 मीटर में था, इसका इमेज कहाँ बनना था? रैंडमली अगर आप बताओ तो कहीं ये साइड पे बनना था, ठीक है? और बहुत दूर है तो मतलब हम उसको बहुत इंफिनिटी बोल रहे थे. लेट्स से कहीं तो यहाँ हमने फोकस में स्क्रीन रख दिया, ठीक है? Now, as we are moving this closer, इसको कहाँ डालना पड़ेगा हमें? पीछे दूर जा रहा. हम यहाँ पे वही देख रहे थे ना. As we come closer, our images were going far away. बट ये स्क्रीन की बात हो रही थी क्योंकि इमेज हमको कैप्चर करना है तो स्क्रीन में करना है. बट ये क्वेश्चन पूछ रहे हैं, तो पूरा क्वेश्चन थोड़ा कंफ्यूजिंग बनाने के लिए पूछ दिया कि हमें पता है कि जब स्क्रीन आप मूव करोगे दूर तो इमेज डिस्टेंस बढ़ता है, ठीक है? इन्होंने बोला स्क्रीन को तो वहीं रहने दिया, वो स्क्रीन को मूव ही नहीं कर रहे, वो लेंस को मूव कर रहे. तो आप लेंस को यहाँ मूव करोगे कि यहाँ मूव करोगे? इस साइड, बिकॉज आपको डिस्टेंस इंक्रीज करना है तो आप लेंस को इस साइड मूव करोगे. तो दैट इज वेयर द कैच ऑफ द क्वेश्चन इज. ऑफ कोर्स वी हैव टू एक्सप्लेन व्हाई थ्रू आवर प्रॉपर रीजनिंग using formulas and all. We'll come to that, like mirror formula, we have lens formula also. But then purely by seeing this diagram, you should logically be able to answer कि अच्छा इसको तो ये साइड ही मूव करना है. फिर आपका लेंस फॉर्मूले में कुछ गलत आंसर होता होगा बिकॉज उसमें साइन कन्वेंशन में बहुत मिस्टेक हो जाने का कभी भाई. और आपको लॉजिकली पता है कि यहाँ मूव करना, तो आपको पता है आपका आंसर भी कैसा है. दैट वाज फर्स्ट क्वेश्चन. इज एवरीबॉडी क्लियर विद दिस पार्ट? Because our image is forward farther, so we image distance increasing, but then I'm keeping my screen fixed and I'm moving lens. So the only option that is left for me is to move this on this side because I have to increase what? Image distance. What happens to the size of image of the flame formed on the screen? What will happen to the size of image? Again, ये यहाँ था, यहाँ था. What will happen?
It will slowly diminish.
It will slowly diminish. Okay, one is saying slowly
As we
diminish.
push the object closer to the lens, it will slowly increase.
Okay.
It will
Yes.
increase.
As you are moving this very closer, so वो diminish से कैसा होता जाता है? बढ़ते जाता है, बढ़ते जाता है, बढ़ते जाता है. So we see that it actually goes on increasing, goes on increasing. Okay, even at the final part where it completely shifts the location, still it is not. Okay, so image की size क्या होनी है? बढ़नी है. And the next question, what is the next question? What difference is seen in the brightness of the image on the plane of the screen? How will you comment on this? Okay. I'll give you a hint, okay? Think. जब मिरर में बात करें, छोड़ो मिरर को नहीं बोलते हम, सारे जो लेंस यूज करते हैं जिससे आग लगा देते हैं, वो पेपर को जला देते हैं, let me kill them and then we also failure on सब let them also. So सारी रेज जो दूर से आती है वो उधर कॉन्सेंट्रेट होती है, तो एकदम हम अगर वहां मिरर लगा देंगे तो वो स्पॉट एकदम ब्राइट दिखेगा या बहुत डल रहेगा? बहुत ब्राइट दिखेगा, ठीक है। तो जितने वो रेज एकदम क्लोज होते आ रहे हैं तो वो भले वो इतना छोटू सा इमेज है बट वो बहुत ब्राइट इमेज है, ठीक है। वो सारी की सारी रेज के एकदम क्लोजर है। बड़े इमेज में क्या हो जाएगा, वो रेज जो थोड़ी क्या हो जाएगी, दे मूव ऑल टू डिफरेंट पॉइंट्स और थोड़ी डाइवर्ज होगी रेज। आई एम नॉट सेइंग रेज डाइवर्ज इन द सेंस, जो रेज वहां मीट कर रहे सारे, अब ये सन का इमेज था, ये सन का इमेज जब यहाँ बन रहा है, सो इस पॉइंट का इमेज भी यहाँ पे रे गिर रही है, ये वाले पॉइंट की रे भी यहाँ पे गिर रही है, और इतना डिमिनिश सारी रेज ऑलमोस्ट यहीं मीट करे, तो आपने बोला ब्राइट। इस सन का इमेज अगर इतना बड़ा बनता तो ये वाली रेज जो है यहाँ हिट कर रही है, ये वाली रेज जो है वो दो रेज मिलकर यहाँ इमेज दे रही है, ये पॉइंट का यहाँ इमेज, ये पॉइंट का यहाँ इमेज। तो जब एनलार्ज इमेज होता है तो रेज क्या हो जाती है, उनको काफी स्पेस मिल जा रहा है बाइफरकेशन के लिए। सो इस केस में इंटेंसिटी ज्यादा है, इस केस में इंटेंसिटी ज्यादा है फर्स्ट वन में। तो हमारे केस में इमेज की साइज बढ़ रही थी या कम हो रही थी? तो हमारा इंटेंसिटी क्या हो जाएगा, कम हो रहा है ज्यादा? कम हो रहा है, ठीक है। Yes, where are we? Where is that question? Yes. What is seen on the screen when the flame is very close at about 5 centimeter to the lens? So यहाँ पे ला दिया हमने, स्क्रीन को तो हिलाया ही नहीं हमने, ठीक है। तो हमने बहुत ही क्लोज ला दिया है बिटवीन एफ एंड, ये तो हमें पता है इधर कुछ इमेज बननी है, ठीक है। तो image will not be formed because in this case virtual image is formed behind the object। जैसे आपके केस में किसी का 2f f2 के बीच में था, किसी का beyond f2 था, whatever, but it is behind the object। Did I say image? I guess so. This thing happened while this. Sorry. So these 4 questions are clear. Similarly, we will solve the next question, but this time with proper reasoning. So we will move to lens formulae. And before that, yes. So before that, I'm so sorry we just could not discuss this part. Gave you the question, but then in other. So when we are using which lens is this? Concave. So when concave use कर रहे हैं और यहाँ पे आपका F2 to F2, and let's keep your object anywhere and give me image formation for this. I do know I gave you some similar question for 3 rays ka formation, but then I have to discuss something. So keep your object between 2f and f, let's say, okay, and give me image of this particular object for convex lens. Sorry, concave lens. And a piece of advice, don't draw this very chintu, draw it slightly good amount of height के साथ। If you're done, please show me. We have already done this for the. Who was asking me? I think Anuj, you were asking me about, and I told you prism का जब आएगा. So the thing is, prism comes in next chapter, and next chapter I think we have planned to skip that and go to electricity. Is that we decided here or some other class? So you will have to keep a note, and either others can also keep a note that we have to discuss speed of light of different colors of light in prism part. Okay. All right, so we just have a power left. We can do that. We are almost about to close the chapter. All right. So one interesting thing that is happening in this case, it's good that I asked you to draw it. So where is the image form? Okay. I think in first part everybody was correct. Like there was nothing. I'm so sorry. I'm so sorry. Yes, I think somebody also did this mistake. And I told her that you're wrong somewhere. And so see, it happens with me also. It can happen with you during examination also. Please make sure you do not do. You will not have somebody telling you that, ma'am, you have drawn it like this. Nobody will come and tell you. So yeah. So where were we? I was quite lost. So yes, thank you. So since this is diverging lens, this is going to diverge. But the way it will diverge such that it passes through focus. Okay. The other ray was optical ray. Okay. And the thing is, some of them were thinking ये दो रे बना दी तो इमेज तो बनने ही नहीं वाला, ऐसा शायद कहीं आएगा कि ये दो रेस का मीट ही नहीं कर रहे हैं. ठीक है. And I think the one interesting thing that has happened is this one, and images from here ऐसा भी वाला कुछ तो हो गया है. ठीक है. So in case of what do we call this?
Optical.
Concave lens. Okay, in case of concave lens, these rays will always meet behind the lens. That is for sure. So you will not think of this meeting here. Okay, so we cannot take that. So the last ray is not required. Is what I was telling him. I think him only. So in this case, this is one ray. This is second ray, and we say that the image form for concave lens is where these two rays meet, and where if I see from here, this ray is coming from this path and this ray is coming from this path, they do actually meet at this point. So I say this is my image. Okay, so we choose these 2 points. Let's look at it like this. We are only left with length formula, power of length, and then we are done. I don't think so. We have any questions in what? We do not have any questions in NCRT. He said it is her his. Who is it? Shots. All right, so this is clear, this part, and this is very interesting that many of your diagrams clear. It is good that you do it. Even I did the mistake. You yourself saw that it happens. You are just in the flow and you do it. So I hope you remember it during your examination and not between eyes. All right, so we'll do the last part. So I said we were solving one question. ऐसा कुछ question NCERT में तो नहीं है. इसी के नीचे का जो question है, we'll be using I said the same scenario. I think it is 32 now, right? It is question 32. Same scenario based question, but then we have to suffice it with proper reasoning. Okay. So in this case, we will be using like for mirror formula. What was the mirror formula?
1 by b plus 1 by u
is equal to 1 by l. Length formula is 1 by b minus 1 by u is equal to 1 by l. And as per sign conventions, we'll stick to sign conventions, and we will always keep our. Are they able to see? So as per sign conventions, we'll always keep our object on like this side. So our u will always be what? Negative. Okay. And f for convex lens is what? Positive or negative? Positive, right? Because rays will come and meet on this side. So that is positive axis. This is negative. Top is positive. This is negative. So this is also positive. This is also negative. And we have to find b. So in most of these cases, like in all cases, except for the last one. So for all these cases, my v will be what? Positive or negative?
Positive.
It will be positive because image is formed on what? This side. Okay. So I am just straight away stating this. We will be solving directly formulas. Okay. And we have, since we have to suffice it with proper reasoning, we have lens formula. And for the diminished part or enlarged part, we have magnification formula, right? What was the magnification formula for mirror?
H dash by h.
Yeah, that is m is what? H. Let's put it properly. So it is height of image, height of object. Okay.
Equals to minus v by u.
So in that case, it was minus v by u. In lens formula, it is v by u. Okay. I'm not going any which ways. You do not have derivation of this. Otherwise, you will have studied another geometry to understand. So that is not that it's straight away this. You know the formulas. Now you know the difference also. Here it is subtraction. Here it is positive sign. It is v by u. Solve. For that you use this. You use the ray diagram, and you of course geometry comes everywhere. It's sign and everything. But then that geometry, it's mostly we will call it geometry because we will be using what like sign conventions. आपकी जो rays hit कर रही है, आप कोई triangles और वो सब जो form होते हैं वही करके आप ये derive करते हैं. All right. So now you will answer the second question. We know the logic कैसे logic first को solve किया वैसे ही second भी है. आप मुझे प्रॉपर रीजनिंग के साथ यूजिंग दीज फॉर्मूलेज, लाइक इन द फर्स्ट केस व्हाट वाज द क्वेश्चन, ऑब्जेक्ट वाज व्हाट एट लाइक 2 meters and focal length was what 10 centimeter, and then they said what if this is coming closer, if this is coming closer, what happens to u value? It decreases. Like why is it a blank silence? आप इतना closer ला रहे हो तो ये value जो ये 2 meter था, 2 meter is how many centimeters?
100.
हाँ, so that's what I'm coming to 1 upon u फिर बाद में जाना है. So this is 200 centimeter पे था, closer ला रहे हो तो ये पहले कितना था? u आपका क्या है already? Negative है. So आप what were we in this question? Like, let's remove this now. Okay, I'm telling you how to answer the question. In second answer, I need you to put everything in your words. Okay. So the first question तो याद है ये 10 centimeter था. Image formation के बारे में हम बात करने वाले थे कि screen को तो fix रख दिया, lens कहाँ move करेंगे ऐसा question था. Okay, how will we? And you yourself told that okay we will move lens on this side. Right, we'll move lens on this side. So reasoning चाहिए तो उसके लिए हमें क्या चाहिए? 1 by v. 1 by v ढूंढ रहे हैं हम because हमें image चाहिए. So it is 1 upon f plus 1 upon u, right? In first case, this is what? This is fixed. 1 by 10. This is fixed. So what is this value? U is always what? Negative. So that if I put only number and the negative sign will become what? Minus over here. It will become something like this. Now, when I am very far, like at 200 centimeter, तो इसका value क्या हो जाएगा? छोटा हो जाएगा. Yes. What did I say? I'm just sorry. So this value is fixed. This value is fixed. This value is the crucial part. So just changing my answer. Okay. This is 1 upon 200. 1 upon 200 or second one मैं closer ला रही. Let's say I just put 1 upon 50. 1 upon 200 or 1 upon 50 में छोटा कौन सा बड़ा कौन सा? This is certainly larger. Like this is 200th part of this one, and this is like this. So this is certainly what? Larger. ठीक है? So in earlier case from this I was subtracting ये छोटू सा part. ठीक है? And in this case I am subtracting इसमें से कौन सा? This बड़ा part. Okay? So this value 1 by v. 1 by v will be what in first case? First case value 1 by v का क्या हो जाएगा? Greater. And 1 by v का value in second case क्या हो जाएगा? जब 1 by 50 subtract करेंगे तो वो क्या हो जाएगा? Bigger value आ जाएगा. Right? और अब इसका reciprocal निकालोगे तो because मुझे 1 by v नहीं चाहिए, मुझे v चाहिए. So this v will be what? Greater. What is this? Initial v. Just okay, let's not put it like this. Let's not put it like this. It's very confusing. Let's solve it. Let's just solve it. Let's take any number. You're bringing it closer. So initial one was, let's say, solve it for 1 by 20 so that you'll understand how to put it in words. And solve it for 1 by 50. Give me answers for, or let's say, give me answer for 1 by 200. Give me answer for both of them. 1 by 200 के लिए आपका v का वैल्यू क्या था और फिर क्लोजर लाया नया v है 20. So 20 के लिए क्या होगा? Give me answer for that. Rather than trying to explain it logically, it is becoming more complicated. So आपका ऑब्जेक्ट पहले कहाँ था? u is equal to minus 200 सेंटीमीटर. आप उसको क्लोजर ला रहे हो. So let's say नया u है minus 20 centimeter. Give me answers for both of them. What is 1 by v?
The first one is 200 divided by 90.
So what is v? 200 divided by 200 divided by 21. All right, we'll do it together. Let's do it. 1 by V minus 1 by what is U minus 200 is equal to 1 by F, which is 10. So 1 by V is equal to 1 by 10. This minus minus becomes plus. It goes on that side, it becomes again minus. If you simply say this is what 200 minus 10, 200 minus 10 is what? 190. By नीचे क्या आ जाएगा? 2000 because I have one. So my V is what? 200 by 19 centimeter. So this is correct. 200 by 19 centimeter मुझे V आ गया. ठीक है? और V पॉजिटिव आया है, which is correct. V वो साइड में ही जाना चाहिए था. So first केस का मेरा V आया है 200 by 19. Now I am bringing my object closer. So I take any random value. minus 20 ले लिया. तो इस केस में आंसर क्या हो जाएगा? 180. इस केस में क्या? V is 20. In this case, V is 20 is saying. In this case, V is 20. So what do you see? 200 divided by 19. This answer will come closer to what? 9.9. आप खुद ही देख सकते हो 19 की बजाय राउंड ऑफ नियरली कर लो तो 20 आ जाएगा और फिर आपका आंसर क्या आ जाएगा? अराउंड 10 आ जाएगा. ठीक है. सो दिस इज नियरली क्लोजर टू 10 और इस केस में आपका क्या आ रहा है? 20. सो इसका मतलब है आपका V का वैल्यू जो है जैसे जैसे आपने ये कम किया आपका V का वैल्यू क्या हो रहा है? इंक्रीज हुआ है. ठीक है. दिस इज हाउ यू विल एक्सप्लेन. आर यू अंडरस्टैंडिंग व्हाट आई एम ट्राइंग टू डू? सो when you're moving object closer, you take any random value. You see that this V was 10. Now V has become 20. So my V value has increased. V value has increased in the sense पहले object यहाँ था, अब object कहाँ होगा? और दूर होगा. ठीक है. So V value is increased. Is this clear?
Yes.
The question was where will you move the lens? Screen is fixed, so you just have to say that we will move lens towards the object because object here. Why are we moving towards the object? Because by doing that we will increase what? P value, because that is what we have to do. Is this clear?
Yes.
We just have to use this. So even in exam you can use these some random numbers to explain, because verbally मैं आपको explain कर रही थी तो I just went in depth. Shortcut I don't know how to explain. This is clear. So in next class we will solve the next sum using a proper reasoning and using these formulas. Like next is what, in 15 minutes? निकलने नहीं दे रहा है.